says again. Good morning, good afternoon, good evening, wherever you may be, and welcome to another episode of SETI Live. This one is going to knock your socks off, and if you want to avoid that happening in front of your family or neighbors, take them off now. We're going to be talking about things you probably haven't thought about, things that are of enormous interest to anybody who finds it intriguing to think about life beyond Earth. And we're going to be doing that with a special guest. All our guests are special, but this guest is maybe more special than many of them. Dirk Schultze-Makuch, who is a professor at the Center for Astronomy and Astrophysics at the Technical University Berlin. He's also an adjunct professor at the School of Earth and Environmental Sciences at Washington State University, and that's in lovely Pullman, Washington. Dirk, welcome to SETI Live.
Thank you for having me. Hello.
All right, let's get right into it. We have a little bit of time, and I want to remind everybody of a couple of things. To begin with, once we've done a little bit of Q&A here, we're going to turn this over to you, where you can ask your questions of Dirk. They will be forwarded to me by our highly trained team here, which includes several of the squirrels from my backyard. We have Rebecca McDonald, we have Lee, we have Barbara Vance, all standing behind the cameras somewhere, ready to take your questions and forward them on to Dirk. Let me also remind you of something else, and that is that these sorts of events, public events like SETI Live, our SETI Talks, our SETI Movie Night, all these things are brought to you from the SETI Institute at their own expense. We're a nonprofit organization. So if you're enjoying these things, don't just sit there and, slurp up the goodies. You send a donation to the SETI Institute. It's easy to do. Just go to SETI.org. All right, Dirk, let's get right into it. You're here to tell us that our thoughts about extraterrestrials is entirely too parochial, if you will, too narrow-minded. We figure that any world that's going to have life, particularly if it's intelligent life, is going to be sort of like Earth. It's going to be Earth 2.0. It's going to, have oceans and the atmosphere and the clouds and so forth and so on. It would resemble our world. It would be a Class M kind of planet. Why is this too narrow-minded?
The universe, as you know, is so big. So there's so many, even so many different places in our own solar system. If you think about Titan with its hydrocarbon lakes on it, its methane atmosphere with monsoon rains of methane. Then we have Europa, which has a subsurface ocean where there may be life. We have Io, which is kind of a volcanic landscape with sulfur and ice all over. And with the exoplanets that we see so much more diversity. Why would Earth be the only place that we really expect life?
Well, okay, it sounds like when we talk about habitable worlds, and people have been talking about habitable worlds probably for at least 30 years, long before, Mr. Spock started talking about them. We always assume they have to have certain fundamental ingredients, like liquid water. I mean, you just mentioned Titan. It's a moon of Saturn. It doesn't have much in the way of liquid water. It has lakes, though, and they're liquid. And they're lakes of natural gas, methane and ethane, things like this. So it sounds like, life can survive in many unexpected habitats. And this idea of habitable worlds, I mean, should we just toss it out, or is there something still to be salvaged there?
Well, this is one of the things. Maybe liquid water is even too constraining. Maybe there are some liquid hydrocarbons in which there could be life as well. Think about methanol. Methanol is a great hydrocarbon. It's a polar compound and has many intriguing properties. And if you think about water, I mean, we think, our bodies are, there's a lot of water and we are dependent on water. But water has also its bad properties. If I look in Berlin here out of the window, there's no leaves on the trees anymore, and part of it is because water freezes and forms ice crystals. And that is difficult for the cellular membranes to take. So you could even say that despite of water, there's life on Earth because life got adapted during its evolution to live with water, basically to work with water. And now it is a great critical compound that we need. But it's but there's other compounds out there.
Well, maybe you can tell us why everybody says, well, if you want to find life, follow the water. NASA's leadership says this to the gullible and says, you got to follow the water, but they don't deny that maybe a place like Titan, which has this liquid natural gas, maybe that could be biology too. What is responsible for this sort of blindered view of what life requires? Is it just history?
Well, it is simply because we have only one example of life, and that is Earth. And if you have statistics of one, you don't have much of a variety. So since water is so critically important for all life forms that we know on our planet, then this is the safest bet to go. But if we want to find truly exotic life forms that are very different, then we have to look at other environments, like, for example, in the hydrocarbon lakes of Titan. I mean, there's not only hydrocarbons, there's also ammonia water slurries in the subsurface that interact with the hydrocarbons. And they could actually be some kind of a habitable environment where life could even originate.
Okay, so we're finding that life is, if you will, plastic. I don't mean that it's made of plastic, not much of it is, but that it can adapt to all sorts of environments. Maybe you give us a couple of places where we find life where you might not expect it.
Well, for example, one place where I do a lot of work is a liquid asphalt lake in Trinidad. And in that liquid asphalt, it has a water activity of lower than 0.5. That means there's not much water available for organisms to take off. And so this was a big puzzle, and to say, how do we resolve that? There shouldn't be any life, but yet we found life. And what it was that there's little micro droplets of water within the liquid asphalt. And that were basically all ecosystems thriving and interacting with the hydrocarbons. From the hydrocarbons, there were the nutrients that they took, and in this liquid water droplets, that was the water. So that worked. And in another place, for example, in the hyper-arid area of the Atacama Desert, which is a nice analog to Mars, there's different kind of salt rocks. And within the salt rocks are cyanobacteria and other bacteria that draw water directly from the atmosphere via a process called the liquescence.
So go ahead.
Yeah, it's basically the same thing. You have a salt, and you have in your salt dispenser. Did you have scrambled eggs today in the morning? Did you use a salt dispenser? And there are some rice grains in it, right? Because otherwise the salt would draw the water from the atmosphere and would make it clumpy. And that's why you have the rice grains. They're even more hygroscopic. So if you live on Mars, then that would be a great adaptation if you can take directly the water out of the atmosphere.
Just for clarification, when you say liquid asphalt in Trinidad as a place where you'd find life, do you mean that, sort of tarry substance? I watched the workmen outside my window here pouring on the streets to resurface them. Is that what you're talking of?
Actually, yes. And they use asphalt, the liquid asphalt. There's a heavy hydrocarbons. They're called asphaltenes. And to pave half of the streets of New York with that. They exported it, actually.
Yeah, I see. So they've managed to monetize their unexpected life. We call these extremophiles, right? This kind of life. I mean, the famous examples are, bacteria that they find in nuclear reactors or in the fuel tanks of aircraft, that kind of thing. But I mean, that says that life is, able to adapt to environments that we personally wouldn't be first on your list to go live in one of these places. But that doesn't mean that, if I find a place that has these conditions, that there's life. I mean, there's a difference between having life exist and getting life started, right?
Right. Well, yeah, and we think that in order to get life started, that will be probably much more difficult. The parameter space is probably much more constrained to have an origin of life. And that's why we don't know, how common life is in the universe. because the persistence of life, once you have life, it seems to be, you know, it's very difficult to eradicate even if it's once there. It's just reproducing and moving everywhere as long as there's not completely horrible conditions. But the origin of life is, of course, much more difficult to grapple with.
Okay, so we still don't know the answer to the question. Well, yes, difficult conditions, but life will get started versus difficult conditions, life could survive there. I asked an astrobiologist here at the SETI Institute years ago, Rocco Mancinelli. I said, look, if we haven't found any life on Mars yet, but if we took all the biota of Earth, so we just take all the bacteria and all the single-celled organisms and the giraffes and the elephants, and we just throw it all. I mean, this is an expensive project, and we just throw it all onto Mars and come back a year later. Would any of it still be alive? And he turned to me and he said, yes. And then he went back to his email. So I thought that was interesting because we haven't found any life on Mars. Maybe the problem is it just simply hasn't gotten started.
Well, I think that would be a fascinating experiment. And I also think that some of them probably would survive. And the ones that would survive are probably those that would be adapted to extreme desert conditions, like the ones that I just told you about, those that can take the water directly out of the air. Because they're in the southern highlands of Mars, there is salt rocks. There are lots of salt rocks. And so if they can survive on Earth, I think they have a shot to live, to survive there as well and to live there. And they maybe not even have to go so deep into the crust because the salt automatically will protect them from the radiation too. And at the same time, they can draw on water. And so if you put it really to the edge or so, you would say, well, maybe when we look for life on Mars, we should not search for water, but not follow the water, but follow the salt.
Follow the salt. Okay, well, that's good. I want to remind people that if you hang on here, you'll have a chance to ask your questions of Dirk. Also, Rebecca has kindly listed some of the places where people are tuning in, Dirk. And first on the list is Berlin. So some of your neighbors are watching this. Make sure that they don't flatten your tires or something. Also, the UK, Greece, New Jersey, Australia, Johannesburg in South Africa, Denver, India, Sweden, Saskatchewan, which is now its own country, Meekatharra, Western Australia. I don't even know where that is, but wherever it is, they probably live underground. People want to know when you expect to hear a signal from ET. This is just a question that came in here. Given the fact that life can adapt to so many different environments, I mean, okay, bacteria, does this also extend to fairly complex life like, your pet dog? I mean, they don't seem to be able to adapt to too many environments. I don't see them living in a jetliner's fuel tank.
That's true, but you would be surprised. There's a lot of multicellular, macroscopic animals and plants that can survive in very extreme conditions. I mean, there are still lizards that are living in the desert, that they actually have these hygroscopic grooves to attract water, for example. There we have the crucian carp that can live or survive for 3 months in Swedish water without any oxygen. We have the Pompeii worm that can take huge temperature differences and lives on the ocean bottom. So even then you have the tardigrades. I mean, that they're going dormant, but they can take extreme stresses.
Tardigrades.
So I think you have to calculate that in too. And I think if a planet is habitable long enough, then basically life will find a way, or evolution will find a way to adapt it and to become more complex. If you look at our evolution on our planet, then we see that the key transitions seem to have happened several times and using different kind of biochemical pathways. So there seem to be lots of opportunities.
Well, Let's go a little bit farther into this land of speculation, if we could. You know, I've heard people say that the 21st century will be the century of biology, right? The 20th century, we saw a lot of work in physics and astronomy, you know, the physical sciences, even chemistry, but that this century will be biology because we have now tools that allow us to change biology, to change the DNA of some organism, CRISPR technology, and so forth. And that sounds to me like, okay, maybe we'll find that our own solar system doesn't have a whole lot of life in places like, Europa or Titan or, some, for that matter, even Pluto. Pluto has some slushy water under the surface there, and I don't know if anything's alive there. It sounds like a tough way to make a living. But if could we not, now that we're in an age where we can think about engineering entirely new forms of life, new organisms, do you think it's likely that by the end of this century or maybe the end of the next century, we'll develop life that can survive in all the other places of our solar system where it's even remotely possible? I mean, are we going to fill our solar system with life even if it isn't there now?
I don't know how likely that is. I mean, we are still far away from that. I mean, of course, there's the other question, should we really do that, genetically engineer organisms, whether microorganisms or anything bigger, and basically populate the whole solar system with genetic freaks, if you want so. I mean, it will take a while too to explore whether there's not indigenous life. I mean, if you look on Mars, I mean, Mars is a heterogeneous planet too. There's a lot of different niche environments. And until we've really figured out to prove that there's no indigenous life, I don't know whether you can even prove it, that there's no life on Mars, You can prove that there is life on Mars, and I hope to see that and at some point. But it's very difficult to say there's no life. And of course, if there's indigenous life on Mars, we shouldn't bring our genetic freaks over there and populate Mars.
Well, but that's a moral objection, if you will. I mean, that's not so much a technical objection, right? I've heard people bring this up at conferences. They say, suppose we go to Mars and it turns out that 1 meter below the surface is all this life, right? I mean, microscopic, but it's there. Do we have the right to go in there and plant whatever, like potatoes or whatever we're going to grow on Mars so that we can settle it? And maybe that wipes out the indigenous population, but tough for them. They had 4 billion years to enjoy Mars. Now it's our turn. I mean, that's a philosophical thing as opposed to a technical thing.
I guess you have a point with a technical thing. Although I would, if we have indigenous life on Mars, especially if it is of a separate origin, then that is a scientific treasure trove, right? What we could all figure out, how different life could evolve. And even if that life is related to us because it came, 4 billion years from a meteorite from Earth, and it would have adapted very differently. It might have changes in its DNA. It maybe have very different proteins. It would be kind of stupid not to explore it and actually to figure it out and understand it before we do anything else with it.
Okay, so you're saying, hands off until we've satisfied ourselves that we have all the examples of life on a different world in bottles in a laboratory somewhere, and now do what you want. I mean, I'll be devil's advocate here, although I don't know about the devil. That's an extreme life form. But in the sense that it seems to me that at some point, since it will become possible for us, I assume, to engineer new forms of life, to take some sort of bacterium and re-engineer it so it can survive on Mars or Titan or Europa or Enceladus, all these places, that we would think, okay, that'll be a good high school science fair project for somebody to populate some of these places that, they just have a lifeless chemistry going on, and that any solar system we find that has any life will be riddled with life.
I think actually, see, there's something that I think where we think Earth-centric too, because I think if there's indigenous life on Mars, it will have had about 4 billion years to adapt to the conditions on Mars, to the extreme condition on Mars. And we are so full of ourselves and first think, okay, we have our Earth microbes that are maybe even better adapted to Mars. I don't think so. And then we can do within 50 years or do some genetic engineering and get our Earth microbes better than the indigenous Martian microbes that had those 4 billion years to adapt.
Well,
so,
yeah, but it sounds like what you're saying is that Darwinian evolution is a wonderful engineer, right? It's slow. It works on timescales that are hundreds of millions, even billions of years, but whatever it produces is guaranteed to work. And we might not be able to do that in the laboratory quite so quickly.
Right. And if you think about Martian life may have found some kind of solutions to the extreme dryness and conditions on Mars that actually Earth's life hasn't found, because life on Earth doesn't have to cope with those extreme conditions.
Now, what about intelligence? We haven't really mentioned intelligence here. You know, the kind of life you find on television every night. Just because I give you a million planets that are sort of like the Earth, or enough like the Earth that they've cooked up biology. There's something alive there. You know, do you think a high percentage of them will ever produce intelligence, or is intelligence going to be fairly rare, maybe extremely rare?
It depends how you define intelligence, I think. So for one thing, there's a lot of intelligent life on Earth, not only humans. You can argue about that, right? Yeah, I know. But
they don't fight back. Yeah.
Right. Well, dolphins are definitely intelligent. The octopus is intelligent. Elephants are intelligent. So there's a lot of different species on our planet. Ravens, crows are very intelligent, that are actually fairly intelligent. Now, so that has evolved several times in different ways. But technologically advanced intelligence has only evolved once. And this is, I think this is a big puzzle, because there was so much time for it. I mean, we have the octopus on our planet is there since 350 million years or something like that, but it never developed technologically advanced intelligence. We had actually at some point a kangaroo that was a carnivore, 75 kilograms heavy, and had this, nice fingers, could do things, but it got extinct. We had velociraptors, that were quite intelligent, but they didn't evolve further to become technologically advanced. So it's difficult to say. There seems to be something very special about us that is difficult to crack, to put your head around it.
Well, but it's true. You look around and you say, okay, there's been life around here for, 4 billion years, but we're the first species only in the last, couple of 100,000 years that's gotten smart enough to have a SETI live session. So that suggests that, maybe intelligence is very rare. But on the other hand, Frank Drake has said many times, usually at lunches, he will say, yeah, but of course. I mean, that doesn't mean anything, because whatever species is the first to become intelligent, in our case, Homo erectus, Homo sapiens, some sort of Homo, if they'll look around and they'll say, hey, we're the only ones, and say, see, it's a miracle, Bob. I mean, it's very unusual to get intelligence, but the first such species is always going to say that.
Well, but the species could have become extinct as well. We can become extinct. We are not immortal, or at least not yet. So we are not. So and then there could be then at some point after us, there could be another species. Maybe then the kangaroos or elephant becomes more intelligent and develop technologically advanced intelligence. But the problem is just, I think you had so much time, and there seemed to be so many other opportunities before, and none of them became technologically advanced. So what is it that is really so truly special about it? I mean, they say, okay, we had language, but some of the other animals are pretty good in language too. And why didn't they evolve further on? But
Yeah, yeah. Well, the dolphins have language apparently, but I think their problem is they can't pick up tools. Not easy, not in a way that allows them to use those tools. That's my personal opinion. We've got a lot of questions coming in here. In another minute or two, we'll go into those. But I'm going to just bug you with two things. First, I want to thank Bro Hansen. Not sure of the pronunciation. Don't even know if that's a first name, a last name, a middle name, or just a surname. But Bro Hansen gave us a donation, which we really appreciate because, as I mentioned at the top of this session, this is all run on the basis of a nonprofit institute. So your donations really help. Here's my last question to you then, Dirk, before we go to the questions from the audience. And that is, okay, we've been talking about biology, its adaptive qualities, its ability to, survive in many, many different environments, a fact that we have underappreciated in the past. But, the other thing about intelligence, if you get that far, is that intelligence can maybe program into other intelligence into things that aren't alive at all, just into machines. And people who work on AI and so forth, they say, yeah, by the middle of the century, right, the great German novel will be written by a machine and not by somebody sitting around in Wuppertal or whatever. Okay, so what about that? I mean, if we go to other, maybe we don't go, but we survey somehow other solar systems where life is taken hold, would you not expect to find, if you will, machine intelligence at the top of the pyramid?
I agree with you that that would be probably much more likely, and especially we should maybe arrange our search parameters to this, because right now we're looking for Earth-like planet, a habitable planet, but other planets, if you think about a machine, for a machine, Earth isn't that great. It will just rust away with time, right? So there's a problem with it. So to be on a, kind of lifeless planet like the moon or something like that would be much better for a machine. So we may have here to adjust our search parameters as well, because I think you have a great point there. I would expect that as well, that at some point you would evolve or would get machine intelligence. Not necessarily, but there's a big likelihood. And in a lot of circumstances, if you have technologically advanced life, I would expect that, yeah.
Okay, well, I'm sure that the first machines to take a close-up look at the moon will find it populated by other machines. We're going to go to some of these questions here, Dirk. A whole bunch of them. They're really good ones. Also, by the way, Scotch just made a donation. I love that name, Scotch, and it seems somehow counterintuitive that somebody with the name Scotch would make a donation so readily, and we really appreciate that. Okay, let me just read one of these questions. It seems to be... well, here's one. Yeah. Okay. What are your thoughts on the tardigrades? Some people call them water bears. They're really nifty looking critters, but they're kind of small. They were on the Beresheet spacecraft, I think, that crash landed on the moon. I think this was an Israeli effort to reach the moon. Do you think any of them will survive? Could we go to the moon and find maybe not intelligent life, but all these little water bears sort of hunker down underneath the sand?
I don't think so. I mean, tardigrades can take a lot of stress, can survive space conditions, and you basically can heat them up to 150 degrees C, or you can they can survive for a while in a vacuum, but only in a dormant stage. I mean, they feed off algae and bacteria, and there's no food source there. So they basically just would getting in the dormant stage to the moon, probably survive there for a little bit, but cannot breathe or metabolize or do anything, and eventually will die there. I mean, they cannot be viable. In order for them to actually do something, they have a very narrow range of living conditions or living parameter.
It's sort of like Sleeping Beauty, but no prince to wake her up, kind of thing.
No, and there will no prince be coming there.
Yeah, okay, all right. How about this? While we currently think that life originated on Earth around hydrothermal vents, I know that that's an argument that goes back and forth in astrobiology circles. What other locations could we hypothetically see life originate in should a planet lack the kind of phenomena that we see on Earth with the hydrothermal vents. In other words, the question is, what other paths toward getting life started in the first place might there be?
There are several possibilities, and we don't even know whether there's evolved on hydrothermal vents. I think actually more like a hydrothermal pond on the surface of a planet is more suitable. But one other possibility would be perhaps a tidal flat, because tidal flats have a lot of preferential parameters for that, because you have the wetting and drying cycles, you have high salt content, low salt content, you have energy going into the systems, you have clay minerals. So I think tidal flats would be another possibility. And that could be kind of explained too, maybe that we have life on our planet because we have this large moon, which is fairly rare if you look at the other solar system bodies.
So wait a minute. So what you're saying is tidal flats. By the way, name a place that has tidal flats other than a symphony orchestra.
Well, in front of Alaska, there's on the southern coast of Alaska, there's tidal flats.
Okay, so this is a place where the water. So the water comes in, the water goes back out. You have a changing environment, a dynamic environment there with a liquid.
Absolutely, yeah.
Okay. So tidal flats might be a place where you expect that. Well, that's interesting, but that requires, as you say, the moon, only because the moon causes the majority of the tidal effects on the Earth. But if you took the moon away, if you made that a project for this weekend, just remove the moon, I mean, the Earth would still have tides, but they'd be, only about 1/3 as strong as the tides we have now. I mean, maybe you could do it without the moon.
Maybe that would be interesting experiment. So if you want to do that,
go ahead.
Yeah.
All right. If any of the viewers are planning to remove the moon this weekend, we can at least write it up for the Astronomical Journal.
One thing, though, is that during early Earth times, the moon was much closer to the Earth. So the tides would have been much bigger. And so, the moon would have made much more of a difference.
Okay.
So you should do that for early Earth and 4 billion years ago, the experiment.
Okay. There was a question here that I thought was sort of interesting. Yeah, what about the benefits of the James Webb telescope, which I think is finally supposed to be launched maybe this year, over other telescopes and searching for life on other worlds? Is this going to be a game changer in any sense?
I mean, it will be great to get as a higher resolution, to get better picture, but I don't know whether that will be a game changer. You would really have to have something like the Starshade mission, where you can just get for the exoplanets, to get a pixel size for the planet alone, not the planet and the star together. And if you have a pixel, at least one pixel alone for a planet, that would be a game changer. And then it will be still difficult, but then you could maybe infer, okay, does this planet has ice caps, or does this planet maybe have an ocean? Do we see seasonal changes or so? James Webb, I don't think that it will do that, at least not with the exoplanets, that we will get probably some more information whether that planet has an atmosphere, or, but then only we'll know, okay, does it have a carbon dioxide atmosphere or a methane atmosphere? Maybe some water vapor, but not really more.
All right, so a big step forward would be able to actually see the planet, even as only one pixel, because then you could see the changes in the brightness or something about the spectrum or something like that,
exactly.
Right? Yeah. Okay, let's see, what else have we got here? You have to... Yeah, if this one is from Sabine in Berlin, actually, and she asked, if there turns out to be life in Titan C, what would stop this life from migrating onto land? This didn't seem to be a problem on Earth. If you just waited about 3 billion years, the life takes up residence in a place it wasn't before. Is there any real showstopper in moving life from the ocean, whatever that ocean is?
Of course, this is highly speculative. It's difficult to say, but if we compare to Earth, you know, the only example really of life we have, it took life quite a long time before it moved from the ocean to the land. So there were a lot of kind of adaptations to it. Now, Titan is a very cold place. And if there's something happening, it's happening very slow. So maybe there is not enough time to move it. You know, there are physical and chemical laws and biological. So there's nothing in the laws of biology that a life form could not, for example, live for 1 million years. You know, maybe there's if there's life, organisms. In my science fiction novel, for example, I had boulder-like organisms that breathe once every 100 years or 1,000 years, right? On Earth, that wouldn't work because there's so much radiation coming in from outside, from the Earth itself, that we constantly have to repair ourselves. But if you're on Titan, you're far away from the sun, and you still have a thick atmosphere, so you could get away maybe with much longer lifetimes. There's no biological law to say, okay, you cannot live for 1,000 years or 10,000 years or even longer.
I'm certainly happy to hear this optimistic assessment of the possibilities. Personally, maybe I'll go walk into a meat locker later this afternoon and just sit there for 1,000 years and see if it helps. I'm a little curious, actually, Dirk, to hear your thoughts on the claim in the past 6 months that there might be floating life on Venus and the clouds of Venus because of this phosphine gas detection, as it is claimed to be.
I found that very intriguing, the detection. I think where it stands right now, the phosphine detection still stands, but it's quite a bit lower than originally claimed. You know, this is a good question. I mean, I proposed that before, that there may be cloud life on Venus or in the Venusian atmosphere, that there's microbes living. Now, I mean, it is difficult for us to imagine it, and we don't see that any Earth microbe could survive there because sulfuric acid concentration is 75 to 80%, pH is way below, and of course there's other challenges. On the other hand, you would have some nutrients. You have elemental sulfur that could protect the microbes over there from UV radiation. You have some water, of course, that's bound into the sulfuric acid, and then what would be some kind of mechanism to get it out. It is definitely extremely challenging, but I wouldn't preclude the possibility. I mean, only because we don't have an organism on Earth that could survive there doesn't mean that it's impossible. That would be, again, Earth-centric, just to say, okay, we don't have an organism that can do that. And the reason why I'm saying that is too, because it looks like that early Venus had oceans on its surface. And it was actually in the habitable zone of the solar system early on. So if you had there a lot of life, microbial life early on Venus, and then the conditions got worse and worse. Now, did that happen catastrophically? And then for life, that would be very difficult to adapt. Or did that happen relatively slowly? So if it happened really slowly, maybe those microbes, since they have no other chance to survive otherwise, would have evolved some kind of adaptation to cope with it and to get the water actually from the sulfuric acid that they need. So I think we have to make us free of to be too Earth-centric and just give the possibility a chance. And with the phosphine detection, it was that the authors from MIT did not find any other way to produce this chemically. So we have some kind of paradox. We don't know how to explain it with chemistry, but we don't know how to explain it with biology either. So we have an anomaly, so let's figure it out. Let's go there and look at it.
Yeah, well, unfortunately, finding life in strange places may not give you too many clues about how life got started. It just shows you that life can adapt. Yeah, it give life a chance. Sounds like a Beatles song to me. All right, let's see if we have one more question here, and we're going to let you go. It's probably getting late in Germany now. There are lots of questions here. Yeah. Well, here's one. Your take on the possibilities for life on Europa. I mean, let me rephrase that. I'll take advantage of the questioner and just modify the question slightly. I know people who've spent a lot of their careers considering the possibility of life on Mars. But now that we find places like Enceladus and even Europa with these vast hidden oceans, some of them have switched allegiance and say, yeah, Mars maybe, but maybe it'd be a lot easier and faster to find life on, say, Enceladus. Do you have a favorite place to look for life nearby?
Favorite place. I mean, I really like Titan because it's so exotic. Of course, it's far away. What I love about Titan is if we find life there, it will certainly be a separate origin from life on Earth. And then we can really say, okay, we can say something about the frequency of life in the universe. At least, you know, we have at least 2 independent origins in our solar system. That would mean. So that would be quite cool. On Mars, I think it's probably most likely, but there's a high chance that it's related to life on Earth that was seeded, either from Mars to Earth or the Earth to Mars. Europa is kind of somewhere in between. You could still some kind of envision kind of Earth type of life there, but then it's, you know, behind Jupiter, behind the asteroid belts around Jupiter, and it would be difficult to see basically Europa's ocean with life from Earth. Also, I mean, the surface, there's so much radiation from Jupiter. So you would have to get really deep into the ocean. Now, you like to make these tests, right? So to do these experiments. So Europa is actually quite a nice testing ground in that way. Because if life originated at hydrothermal vents on our planet, then I think there would be a relatively high likelihood that it would be in Europa's ocean as well. If it evolved on the surface on Earth, then it would be very unlikely in the deep ocean, unless there's another way for life to originate. Now, Europa, I think, is interesting too, because it's really the only body in our solar system where I could imagine that there's a bit more complex life as well. Years ago, Lewis Irvin and I did kind of a modeling study of possible ecosystems that could exist in Europa's ocean. So we looked, okay, what was the rate of hydrogen outgassing and other environmental conditions? And then we said, okay, if we see some kind of a simple ecosystem, what could that be? And what we came up with the nutrients when we compared it, the biggest organisms that could be there is some kind of a shrimp-like organism, so like a brine shrimp. Yeah, so it's nothing really big, but of course for us that would be totally tremendously important. It's not only a microbe, but it is actually an animal or animal-like. What could there be? So that would be very exciting.
Okay, well, I hope, as you expressed earlier in our conversation here, Dirk, that we live long enough to see this turn from speculation into observation, and that maybe we'll start importing those shrimp, for use at lunch. I want to thank Dirk Schultze-Makuch for being our guest today on SETI Live. Thank you for your interest, your attention, and in some cases, your donation. Once again, you can help us keep these things going by simply going to SETI.org and hitting all the very obvious buttons. It's getting late there in Germany. Dirk, thanks so very much for being with us. Thank you all for attending, and we'll see you next time here on SETI Live. Oh, and one more thing. Go to the SETI Institute's webpage to check out another event that we have going on, and that is the SETI Talks. They're kind of like colloquia, but you don't have to be a specialist to attend and understand and appreciate and marvel at these colloquia. Our next one is, in fact, going to be about very big telescopes. We talked a little bit about James Webb's here, but, the 30-meter telescope and so forth. all these really massive telescopes that are being built around the world in the next couple of years that could be game changers for all this kind of research. I'm Seth Shostak. Thanks very much for being with us, and we'll see you next time on SETI Live.
Thank you for having me.